Magic methods in Python. Today we'll talk about magic methods, different ones like binary, extended assignment, unary, and comparison. We'll also learn to overload operators using magic methods. Magic methods are special methods that let us implement what a normal method cannot. These are also called dunders as they have double underscores around their names. In Python, we have different magic methods that let us emulate the behavior, like addition and comparison, of built-in types, so we can do this to our own classes. Init is a magic method, and so is eq. What's the use? Let's find out. This is class Mario. Init is the magic method that lets us initialize the lives attribute with the value 7 for the object m. Now what is m plus 2? We cannot just add 2 to m. It is an object of class Mario, not that of class int. So we put the add magic method in this class and make it add the integer to the integer value of this object's attribute lives. Now it can add them. Great, let's see some more such magic methods. We have add for addition, sub for subtraction, mul for multiplication, truediv for division, floordiv, mod, pow, and, XOR, or, lshift, rshift, among others. These are magic methods for binary operators. Let's take an example. This code implements two magic methods, add and radd. Now when it adds 2 to a, which is an object of my class, it prints 3. But what is the radd for? It means 2 plus a works too. Radd is reverse or reflective addition. This means if the interpreter cannot add left to right, it will add right to left. For extended assignment, we have the methods iadd for add and assign, isub, imul, idiv, ifloordiv, and many more. Let's take an example for this. ipow here lets us raise n to the power of 10. For n, base is 2. So the result is 1024. Some operators are unary and only operate on one operand. Some of these are negative, absolute, float, and hex. In this example, 2 is an object of class complement. For it, num is 2. We can calculate the ones complement of this object. This means ones complement of 2, and this is minus 3. 2 is greater than 1, but can we compare two custom objects this way? With magic methods, we can. We have less than or equal to, not equal to, greater than or equal to, and greater than. This class's objects can be compared. The less than magic method takes an integer and compares it to the value of num for an object, which is 2 in our case. And the integer we compare it to is 7. So is 2 less than 7? Yes. And is it less than 1? No. 2 is in fact greater than 1, so this object is not less than 1. A great thing about magic methods is that we can use them to implement operator overloading in Python. This is class myFloat. It initializes the whole and fraction parts of an object. The method showNumber represents the number in the decimal format. The add magic method checks whether the sum of the two numbers' fractional parts is greater than 9. If it is, it adds the two numbers' whole parts to 1, and this is the new whole. Then it adds the two fractional parts and subtracts 10 from this. This is the new fraction now. And if sum wasn't greater than 9, it simply adds one whole to another and one fraction to another, and this is the resulting whole and fraction. The two numbers are 3.7 and 3.4. What do we get when we add the two? Since 7 plus 4 is 11, which is greater than 9, whole is now 3 plus 3 plus 1, which is 7. And fraction is now 7 plus 4 minus 10, which is 1. So the resulting value is 7.1. We just created two objects to hold floats and then added them accurately. This is the magic of magic methods. They let us do with custom objects what we do with those like integers or strings.